Welcome to this explainer. Today we're taking the mystery out of motion and resistance, and we're going to master the physics of friction forces. If you've ever found yourself tripped up by the invisible forces acting on everyday objects, well, you're in exactly the right place. We are going to break down the top 3 exam questions you are practically guaranteed to see on this topic. Let's just dive right in.
Okay, so here's our roadmap for today. First up, we'll look at the invisible stopping force. Second, the root cause, which is surface roughness. And then, we're going to hit the ultimate exam cheat sheet. Question 1 on reducing friction. Question 2 on its advantages. And question 3 on its disadvantages or hidden costs.
Section 1. The invisible stopping force, the basics of motion and resistance. Now think about this for a second. If you exert a pushing force on a stationary wheelbarrow, it produces motion, right? It just starts moving. Force produces motion. But conversely, imagine a super fast golf ball flying right towards you. If you catch it or maybe block it with a stick, you've essentially applied a force to stop it. So a force is actually required to both produce motion and stop moving objects. Pretty simple so far, right?
Let's apply this. Imagine a football just resting on the ground. You run up, you kick it. You just exerted a force, and boom, as a result, the football starts moving. But watch what happens next. After covering some distance across the field, it slowly comes to a halt. Now hold on. Think about our rule from just a moment ago. A force is required to stop a moving object. But out there on the open field, nobody touched the ball, nobody caught it. So we really have to ask ourselves, what exactly is stopping the rolling football?
Well, the answer to that mystery is ground friction. Whenever you see a moving object slow down and stop without any apparent interference, it's the friction force at play. And for your exams, you absolutely need to know this formal definition cold. So, friction force, which is denoted by a lowercase f, is a vector quantity. That just means it has a specific direction and it's measured in newtons. But most importantly, it acts in the exact opposite direction of the movement to always resist moving objects. So, if your football moves to the right, friction pushes to the left. It is literally the ultimate resistor.
Moving on to Section 2, the root cause, surface roughness, and why friction exists. Okay, so we know what friction does, but why does it actually exist in our daily lives? Like, what is actually causing this invisible pull in the first place? To figure out the culprit, let's compare 2 totally different environments. I want you to picture placing a football on a beautifully polished, completely smooth tile floor. And then place another football on a really rough, irregular gravel road. Now, if you kick them both with the exact same amount of force, which one is going to travel further? Well, obviously, the ball on the smooth surface is going to cover way more distance. But why? It's because friction exists entirely due to the roughness of the ground. The golden rule you need to remember here is this. The larger the roughness of the ground, the larger the friction force, and the faster the object stops.
And honestly, this brilliantly illustrates a really common point of confusion. You might look at a glass table, or maybe an ice rink, and think to yourself, okay, there is zero roughness there, so why do objects eventually stop at all? Well, it turns out, even surfaces that look flawlessly smooth to the naked eye are holding a bit of a secret. If you look at them under a microscope, it reveals these tiny microscopic jagged edges, little peaks and valleys. So yeah, even the absolute smoothest looking surfaces have some sort of roughness that eventually catches and creates resistance.
All right, Section 3. This brings us right to exam question 1, reducing friction and how to smooth things out.
So the exam is definitely going to ask you how we can reduce the friction of any given surface. And you can accomplish this through 3 really simple methods. Method 1 is polishing surfaces. If we polish a material, its physical roughness naturally decreases, making it smoother and instantly dropping that friction. Method 2 is applying lubricants, like machine oil or grease. You see, the friction of certain liquids is actually significantly lower than many solids, so adding that fluid layer makes an absolutely huge difference. And finally, method 3 is using ball bearings in mechanical systems.
Now, what's really fascinating here is the clever mechanics behind that third method. Like, why do ball bearings work so well? Well, it's because they fundamentally change the type of friction occurring in a machine. Instead of 2 flat metal pieces just brutally grinding and dragging against each other, ball bearings convert that heavy sliding friction into rolling friction. And rolling is vastly easier and encounters way less resistance, which saves incredible amounts of wear, tear, and energy.
Moving right along to Section 4, Exam Question 2, Friction's Advantages and Why We Actually Need It.
Okay, so up to this point, friction kinda sounds like an annoying obstacle that just wants to stop everything we try to do. But on the exam, you're gonna need to prove why it's actually our invisible best friend. Let's do a quick so what check here. Why does this actually matter? Well, think about something as basic as walking or running. We only manage to push ourselves forward because of the friction between the soles of our shoes and the ground. Without it, we'd literally just slip endlessly in place like some cartoon character on a frozen lake. Next, think about holding nails in wood. It is purely the frictional forces gripping the sides of those nails and screws that actually hold our houses and our furniture together. And finally, lighting a matchstick. We absolutely rely on friction to generate the spark and heat necessary to set that match on fire. Without friction, our basic daily functions would be pretty much impossible.
Section 5. Exam Question 3. Friction's disadvantages and the hidden costs.
Now, to bring complete balance to your exam answers, you also have to be able to explain when friction acts as our worst enemy. So the crucial point here is that friction can also be a massive hindrance. First off, it slows down moving vehicles. It acts as a constant drag that drivers and pilots have to constantly fight against. And that means burning a lot more fuel just to maintain your speed. Second, it causes massive energy wastage in machinery. Just to overcome that internal friction, machines have to use a ton of extra electricity, which obviously greatly increases the cost of production in factories. And third, it produces serious wear and tear. As parts rub together day after day, friction damages them. That means machine parts are inevitably going to break down over time and require some really expensive replacements.
So you've now mastered the core concepts, but there's definitely a deeper layer of mastery ahead. In our future explainers, we're going to break down specific types of friction for you. We'll be looking at static friction, kinetic friction, sliding friction, and rolling friction.
But for right now, I really want to leave you with this final provocative thought. Just imagine waking up tomorrow and friction just disappeared entirely. What would happen? Well, you wouldn't even be able to walk to the bathroom. Your car tires wouldn't grip the road, the screws in your walls might just slide right out, and anything in motion would literally never stop. It would be absolute chaos, right? Thinking about it that way really cements a newfound appreciation for this incredible force. Anyway, thank you so much for joining me on this explainer. Stay curious, keep learning, and I'll catch you on the next one.